Okay, so we're going to go ahead and get started. Hello, first of all, and welcome to part 2 of the BioLab Fundamentals webinar series. My name is Eric Morgan, and I'm a software engineer at MindWare Technologies, and I will be presenting the webinar today. So as usual, the webinar is going to be split into two main parts. We're going to have a walkthrough, and we're going to have a question and answer portion. So the walkthrough is going to cover the remaining topics of configuring BioLab, such as using events, displaying data in BioLab, acquiring audio video, trending, and using configuration files. Once we go through the walkthrough, we're going to move to a question and answer portion where I can answer any and all questions that you have regarding the topics that we've covered today. And throughout the webinar, you can use the GoToWebinar interface to ask questions, and we will have representatives standing by to answer them throughout the webinar. But if your question is good for the group to hear, then we'll wait to answer it till the end. So if your question isn't answered right away, don't worry about it. We'll definitely get to it at some point, but you can feel free to ask them throughout the entire presentation. So we're going to start with a brief recap of what we covered last time. And if you weren't able to attend last time, or if you weren't able to watch the recording, most of what we talk about today is still going to make sense, but I would definitely recommend going back and watching that first part to fill in the gaps. What we learned last time is that BioLab is MindWare's application for acquiring data and for viewing data. And using BioLab, you can integrate physiology recording, events, audio, video, and there are many configuration options related to channel setup and general use of the application that we talked about. We talked about some basic signal analysis and acquisition concepts such as sample rate and gain and filtering. We talked about the importance of naming your channels, something meaningful for analysis purposes. We talked about the different file modes that are available in BioLab and how we can save data. And we also talked about a little bit about triggering, which we're going to talk a little bit more about today as we talk about digital events. So last time when we talked about BioLab configuration, we spent most of the time talking about the settings across the top of the screen, and then the settings in the first two tabs, which pertain to channel configuration. And in this webinar, we're just going to continue working our way through the tabs left to right, talking about the remaining configuration options in BioLab. And we're going to start with events. Now, what is an event? An event is a point of interest in a file. These events might occur at predefined times, such as when you're using a stimulus presentation package and you know that that system is driving your experiment. So you know what time certain tasks are going to start and end, what time a specific stimulus is going to be presented. Or these events could be in the moment. You might not know that a certain situation could develop that might be meaningful for analysis purposes, and you'll want to mark that location so that you can draw your attention to it later when you're analyzing your data. So it basically allows you to easily access those specific points in data during analysis. You can narrow in on these events and analyze the data around them to understand what might have been going on physiologically with your subject at some specific time point. In BioLab, there are three main types of events that we capture. There are digital events, keyboard events, and network events. And those events can come from a whole variety of sources. They can come from stimulus presentation packages like E-Prime or SuperLab or DirectRT. They could come from custom applications developed in some programming language or MATLAB that are able to send events to BioLab. They could come from some third-party hardware that's able to send those events, or from behavioral coding software such as Noldus Observer. And they can also come from the keyboard that's attached to the acquisition PC. And we're going to start by talking about digital events. And when you open the Events tab in BioLab, you're going to see multiple tabs within that menu that each pertain to the different types of events that I just mentioned. So digital, keyboard, and network. And the first two tabs deal with the digital events. Digital events are events that are sent by an external application via a digital port. Now, some of the applications that are capable of sending digital events include E-Prime, SuperLab, DirectRT, and MATLAB. Now, when I say digital port, I'm referring to the connection on the back of the BioNex that is labeled digital I/O, and it's this connector that links between the BioNex and the computer that's generating these digital events using our trigger cable or our event cable. And if you have a 2-slot or a wireless data center, this might look a little different, but there are still digital ports available on those units. They behave a little differently, and we're going to talk a little bit about the difference in those behaviors as well. What we're doing when we're detecting digital events is we're looking for pulses or value changes at the port. And what I mean by that is a digital line, which a digital port consists of multiple digital lines, can only have really two values. It's either on or off. And we're going to look at that as 0 or 1, 1 being on and 0 being off. And digital ports consist of multiple digital lines, and depending on the type of hardware you have more or less of those available. BioLab is going to monitor the states of these lines, and it's going to sense when they change. And a change in a digital line means that an event has been marked. In an attempt to be flexible, BioLab has various event modes to interpret the pulses differently. So it can handle different sources of these digital events that are capable of only sending an event in a certain way. So as I mentioned, we have two possible values for a digital pulse. We have 0, which is off, and 1, which is on. Now, there are multiple types of digital ports, like I mentioned, which are available on different models of the BioNex. So we have asynchronous ports and synchronous ports. We also have different event modes called individual and summary. And what we're going to do now is go through each of these in detail so we can understand the difference between the types of digital ports that we have available to us and the types of event modes that we have in BioLab. We'll start by talking about the different types of digital ports that are found on the various pieces of MindWare equipment. And to do that, we need to recall a concept that we talked about last time, which is sample rate. Sample rate is the number of times data is sampled per second. So if you have a sample rate of 500, you're sampling every 2 milliseconds. So you have 2 millisecond precision on your data. If you're sampling at 1,000 samples per second, you're having millisecond resolution on your data. Synchronous event ports are sampled at the same rate as your physiology. So you have the same level of precision as the sampling on your physiology data. Meaning that if you're sampling at 1,000 samples per second, you have millisecond resolution on your event detection. Asynchronous events, on the other hand, which are available on the 2-slot in the wireless data center, are sampled as quickly as possible, but they're done in software. They're not timed with the same clock as the physiology data is being sampled. So this can result in less precision timing because it's highly dependent upon the processing power of the computer and the amount of that processing power that's available when BioLab is running. It's pretty easy to identify what sort of port you're working with. First of all, in BioLab, the names of the tabs will also identify the style of port that you're working with. It'll say synchronous or it'll say asynchronous. But you can also identify it by looking at the device that you have. And if you need help identifying which version of an 8-slot you have or which device you have, there's a knowledge base article that has pictures and identification hints to help you figure that out. Now, because of the difference between these two ports and their capabilities, there are different restrictions on how quickly you can send events to them, and BioLab will still be able to identify them. With a synchronous digital event port, your limitation is your sample rate. So as long as your pulses consist of 2 samples, then BioLab will be able to detect those pulses and log those events. If you're working with asynchronous, it's sort of less obvious as to how quickly you can send those pulses. And through some testing and with standard machines, we've determined that if you leave the minimum pulse at 70 milliseconds with at least 100 milliseconds downtime between the pulses, then you're giving BioLab enough time to recognize that a state has changed at the digital port and identify that event. So those are the two main differences in digital ports that you'll find on the different systems that we provide. Now we're going to talk about the different event modes. And we're going to do so by looking at the specifics of the digital port and what's going on each individual digital line and how that impacts the type of event that BioLab sees. We're going to start with summary events, which this representation basically contains a port, which consists of 8 lines on a BioNex, and each line is shown horizontally. If we take a look at this event here, we can see that there's a pulse on line 8 only, which we talked about before can be represented as a 1. What BioLab's going to do when you have it configured for summary events is it's going to take all 8 of these lines and transform them into the binary representation of a number, which we can then look at in decimal form, which we're much more used to, and we could see that this is 128. If you're sending events from E-Prime or SuperLab, you're probably going to be specifying these things as the decimal representation of the number, 128. But behind the scenes, this is what's going on at the digital port, and this is how BioLab is interpreting it. Let's take another example. This time we have a pulse that occurs both on lines 8 and 7. When we do this, BioLab is going to see it again as the binary representation of a number consisting of 8 digits, and that then in turn becomes the decimal representation 160. So when BioLab sees this, it's going to see event 160, and whatever you've defined as event 160 is going to be logged in your data file for analysis purposes. Now, how do we do this in BioLab? How do we configure these events? How do we change it to summary mode? Well, on this tab, we just need to change the event mode to summary, and you'll see that certain parts of the screen become enabled that weren't prior. Now, on a BioNex, which has 8 digital lines, you can have a total of 255 unique values or events defined for that digital port. Now, summary events consist of 2 parts, the event name and the event value. The event value is really just used for communication purposes between your stimulus presentation system and BioLab. But when you're analyzing, seeing that event 3 came in or event 5 came in isn't going to be very meaningful. So we have a mechanism by which you can name these events something meaningful, like task start or task end. And that's what you would do on this screen, so that when you go to analyze based on these events, it's very clear to the person that's analyzing, what is going on during this segment of data. And these definitions are contained in something called a synchronous summary event file. And you can see highlighted here that that file path is flexible. You can have multiple versions of this file with different event definitions in it, and you can choose what file you're using from this screen. The table to the bottom right basically is the contents of that file. It shows you all the definitions that you have in that file. And from this screen, all of them are modifiable. You can add, delete, or edit any of these events by right-clicking on it in the list. If I were to edit the event, we could see that we can change the event name to something more meaningful, such as baseline start, task start, stimulus presented, and we can change the value that's associated with each of these events. Now, it's only possible to create a single event name per value. So at first, since all 255 are named by default, you can't add any new events right away. But if there were some you wanted to ignore, if your stimulus system was sending out event codes that didn't matter to BioLab. You could remove those events and add them back in later, or modify any of the names. And as soon as you try to do anything else in BioLab, assuming that you've made a change to your event table, you'll be prompted to save that event list. So now you can save these as a new file. You can overwrite the previous one. You can store multiple versions of these, which is a way that you can share BioLab with multiple users who are collecting data in different ways. So to recap, summary events are typically used with stimulus presentation applications like E-Prime. And although it's important to understand what's going on at the digital port, when you're working with those applications, you're typically just sending decimal-based numeric values. It's important to name your events well, because when you start to do analysis and you have, 50 unique events and they've only been named after the event number that comes in, it becomes very difficult to keep track of what event means what, and to a person that's running the analysis, if they weren't involved in the acquisition stage of the study, it can be very difficult to sift through all of that. And additionally, be cognizant of what type of device you're using and what type of digital port you have available, so that when you're sending events, that you're not breaking any of those timing constraints. And if you notice that in BioLab, not all of your events are being detected, the first thing to do is make sure that when you're changing these values in E-Prime or whatever, that you're waiting enough time between the value changes so that BioLab has time to recognize them. Okay, now we're going to talk about the other event mode that's available in BioLab for digital events, and that's called individual events. Now, we're going to look at the same representation of the port, but you'll notice the dotted lines between each of the digital lines. And that's because in individual mode, BioLab is going to look at each line individually as opposed to together. So when we see the same exact state on the port as we looked at before, in this situation, only event 8 is going to be marked. And if we look at our second scenario, even though these are occurring at the same time, they're still looked at separately. So in this instance, event 7 and event 8 will both be logged at the same time, but as two separate events. Back on the configuration screen, if we switch our event mode to individual, we can see that the summary portion of the screen is no longer available and the individual portion is. And we could see that each individual digital line can be turned on or turned off, and it can be named something meaningful for that particular event. Now, one advantage that individual has over summary is that you can have multiple events occur simultaneously. The big downside is that instead of having 255 unique event representations available to you, you only have 8. So it really depends on your needs, the needs of the particular study that you're running, as to which of these makes most sense to use. But typically, when people are using E-Prime or some stimulus presentation package, they're using summary events. Now, there's one last thing we need to talk about while we're on the topic of digital events, and that's triggering, which we talked about last time. And if you'll recall, there are a couple different triggering modes available in BioLab. And what BioLab is doing is it's looking for a change in the state of the trigger port. Typically, when people are collecting digital events with our system, they're using one of our event cables or trigger cables. And we need to talk about how that cable works to understand why certain values cause triggers and certain don't. So on our trigger cable, the 8th digital line is also the trigger line. They're one and the same. So when one changes, the other changes. If we were to send a value like 7, event 7, which only toggles these last 3 digital lines, the trigger line stays off, so there's no trigger. If we were to send a value of 128, which is what we typically say to use to start BioLab, that toggles that 8th trigger line, that 8th digital line, which then causes the trigger to occur. And this would be an example for a rising trigger, going from a low value to a high value. But in reality, you could send any value over 128 and cause a trigger. as long as you're starting at some value below 128. Because all we really need to see is that 8th digital line, which is also the trigger, change state from off to on. So that's why when you start acquisition remotely using a stimulus presentation system, we say to send at least 128 to the BioNex, because that's how you trigger acquisition. And on the flip side, if you were using a falling edge trigger, you'd want to go from any value above 128 to any value below 128. All right, so that concludes the portion on digital events, and we're going to move on to keyboard events. So if we click on the next tab over, we see keyboard events, and we can see that keyboard events correspond to the function keys F1 to F11, which are typically found across the top of the keyboard. And these keys can be assigned different names corresponding to events. Now, if you're using something like E-Prime to drive your experiment, then you typically would use these for less predefined events and more spur-of-the-moment events, like the subject coughed, or they stood up, or they sat down, or something that you can't necessarily predict is going to happen at a certain point in time. So you can mark that event, and then later when you're analyzing, if you're concerned about movement noise or some other issue with the data, this event can help identify why that happened. You can also use keyboard events in the absence of something like E-Prime to mark the start and end of tasks. Now, it's not going to be done with the same level of precision because, like we mentioned before, the digital events are sampled very quickly, and this is highly dependent on how quickly can you press the key on a keyboard. But if you don't have that sort of system available to you, you can still use keyboard events to mark those sort of major occurrences throughout your study. There's also a special case, which is F11. So F1 through 10 are all predefined on this screen. So they require some sort of forethought as to what occurrences could happen during this experiment and what do I need to be prepared for. Now, in the event that you don't enter everything that could possibly occur, F11 allows you to enter those at runtime. So during acquisition, you can press F11 and define a custom name for it that gets logged into the file. Now, that does affect your ability to use the events in analysis a little bit, whereas you could filter based on a specific key if you know what key on the keyboard an event was based on. F11, they're sort of all grouped together, but you always have that fail-safe of you can capture that something happened even if you didn't define it on this screen. So to recap keyboard events, they're useful for events that aren't timing critical or for events that aren't anticipated. And they could also be used to do more timing critical tasks if you aren't able to do it through some other mechanism. And what's really nice about keyboard events, and what we're going to get into in the next webinar, is that they can both be inserted during acquisition and post-acquisition. So you can actually, in your file, use the keys to insert events after the fact that you weren't able to tag when you were running live. So we'll talk about that more next time when we talk about data acquisition and file viewing in BioLab. Okay, moving on, we're going to talk about network events. So this is something that's new in BioLab 3.3. And there are two types of network events that we can capture. One is from events that come from a MindWare mobile, and the other are UDP commands. So if you're using a MindWare mobile, you may be familiar with the A and B buttons on the device, which previously were only able to collect events when running in local mode, so saving data directly to the SD card on the unit. But now in BioLab 3.3, we can stream the events that occur when the user presses the A or B button. So within BioLab, we could see that we can enable or disable the events coming from a particular mobile that's connected, and we can name the A and B buttons after the events that they correspond to. So if you're instructing your subject to press the A button when something happens, then we can actually name the A button after that specific event so that, again, you have a lot of context when you go to analyze the data. Additionally, we can detect events on the Bio2 channel on the MindWare Mobile in the latest firmware release. And we also have the ability to stream those to BioLab. Now, event detection on the Bio2 channel is mainly used for synchronizing with third-party ambulatory equipment, such as the Tobii Pro Glasses 2. And we have a knowledge base article that walks through how to hook them up, how to get that working. But what's nice about being able to do this in BioLab is you could actually have multiple units streaming data wirelessly to BioLab and capturing all of the synchronization information that you would need to later align the data and look at your physiology and your eye tracking data in sync. So you would do that right here on the Network Events tab. And again, you can label this as something. So if you're collecting it from Tobii Pro Glasses 2, you could name the event Tobii Pro Glasses 2, and you would know that that is your Tobii sync data channel or event. We also have UDP commands, which is also new in 3.3. And what UDP commands are is a command set that can be sent via a network connection on a specific port, and any application that's able to open a connection on the network and send these text-based commands can connect to BioLab and control it remotely. There are 4 commands that are available. There's a start command, a stop command. You can log an event with any sort of data you'd like in it. And there's a ping command to make sure that the connection is alive, it's available. And we're not going to talk about the specifics of each of the commands because they're defined in the BioLab user guide as well as in a knowledge base article. But those are the types that exist. And it's really pretty powerful because you can start and stop acquisition entirely remotely and without using a BioNex. There is a bit of a drawback, though, in using these, and something that you need to be aware of, and that is because it's network-based, it's subject to network delays. And so UDP commands are particularly useful when timing isn't critical, or if you're using something like E-Prime to do stimulus presentation, but you don't have a BioNex to capture those digital events. If you do, it's always better to use the digital events because the timing is so precise on those. But if you're only running with MindWare Mobile and a router, and you have E-Prime, then this is a way to get your event information into BioLab as precise as possible to still capture that meaningful information. And as I mentioned, there is a knowledge base article on our support site which goes over all of this in great detail and also includes an example of how you would use E-Prime to send these UDP commands to BioLab. So to recap UDP commands, remember that they're subject to network delays, and so they aren't always recommended when millisecond precision timing is required for your events, such as if you're doing startle for EMG, for example. But it does allow for full control of acquisition start and stop, which makes it a bit more powerful than triggering, because triggering you can only start your acquisition. Just remember that it is less precise. And it allows you to integrate stimulus presentation with these systems that don't include BioNexes, that just have mobiles. Okay, so now that we've gone over all of the event functionality in BioLab, we're going to move on to the next tab, which is chart attributes. Now, chart attributes contains the settings that are related to the way data is displayed within BioLab. There aren't a ton of options, but they're all here, and we're going to talk about each of them. The first option is the Y-scale digits of precision. So what this is defining is how many digits or how many decimal places we're going to display on the Y-axis. If you have data that's relatively small in amplitude, you want to make sure you increase this sufficiently so that you can see all the meaningful information on the acquisition screen. We have the chart height, which specifies the height of each individual plot on the screen. Now, this only pertains to the stacked chart, which we'll talk about in a second. If you're using either of the other two options, the plot is going to be auto-sized to the size of your window. But when you're working with stacked plots like we see here on the screen, and we're working with a ton of channels and you want to see so many channels per screen, you may want to make this smaller so that you can see more at once, or you may want to make this bigger so that you can see less channels at a single time, but you can see them much more clearly. And there are three main plot types that we have available in BioLab. The first is the stacked plot, which is what's shown on the screen, and that's where each channel is going to have its own y-axis and its own plot. So this is great for when you're collecting data that are being stored in, or at least measured in, different units of measure that don't necessarily match with other data that you're acquiring. This way you could see them all on their own independent y-axis, and you could see them clearly. You have an overlaid chart option, which basically takes all of the channels and tries to plot them on a single plot. And we do have options during acquisition to offset these channels, which doesn't affect the way the data is stored, but affects the way the data is visualized. So you can separate them and make some sense of what's going on in individual channels. But remember that if your data is being displayed in different units of measure, which could vary greatly from one channel to the other, viewing data in this way might not make a lot of sense, because it'll be hard to see data that has a smaller amplitude and very easy to see data that has a larger amplitude. And finally, we have a graph option, which is the same as an overlaid, except that there's no chart history. So up at the top, there's a setting for chart history length. It basically dictates how much data is shown on the screen at a time. But when you use a graph, that doesn't pertain to the graph. So you only see 1 second at a time. Generally, I would recommend people use the stacked visualization or plot type unless they have good reason to use either of the other two. So those are all the different display options in BioLab, and now we're going to talk about acquiring audio-video. Now, new to BioLab 3.3, we can no longer just collect data from the MindWare video encoder, but we can also integrate with the Noldus Media Recorder, which we're going to talk about in a moment, but really opens up a whole new world of cameras and audio sources that we can work with. We'll start by talking about the MindWare video encoder, which is what we've typically worked with over the years. And these video encoders are either packaged in a separate device or they're actually included in the BioNax system or two-slot system. And with the MindWare video encoder, we can collect up to 4 videos simultaneously. On these tabs here, we have settings for cameras 1 through 2 and cameras 3 through 4. We have a camera name setting, which is important to use because, again, just like when you name your events, if your file is just named subject camera 1, it may not be entirely descriptive as to what that camera is looking at. So you can name the camera after the camera angle or after the subject that it's focusing on, or however your lab happens to be configured. But if you do this and you do it well, then your resulting AV files will have a file name that makes a lot more sense when you go to use that file in analysis. Something that trips a lot of people up, and just something to keep in mind, is you do need to enable the recording of the video before you proceed to the acquisition screen. And that's done through this record enable button. So if you go to the acquisition screen and you can't see your video, chances are you probably forgot to push this button, come back out, enable it, and then it should work. We also have a number of adjustable audio and video levels. We can change the volumes on the sound that's coming into the video encoder, and we can adjust the video settings, so contrast, brightness. So based on the lighting in the room, we might need to tweak these a little bit before collecting the video, because once the video is collected, it's a lot harder to adjust these. We also have multiple video resolutions, but remember that if you record at a higher resolution, it's going to be a larger video file, which some people don't mind working with, but that's just something to keep in mind. And much like we talked about last time, the importance of previewing your data to make sure that you have good quality physiology being recorded, you should also preview your video before you start acquisition. You should probably preview your video before your subject even arrives, just to make sure that your camera is turned on, that they're in the correct position, and that they're ready to go. And so when you press that preview button, you're going to have a preview window pop up, and you'll be able to see the live audio feed. And so By doing this, you can adjust any of the video levels. You can troubleshoot any issues that might have come up. If you're using a pan-tilt zoom camera, you can adjust the position to where you need it to be. Always preview your video. If you are having trouble with the video system at all, there are a lot of moving parts when you're recording audio-video. There's cables, there's the camera, there's the video encoder. If you are having issues, we do have extensive resources on our knowledge base to help troubleshoot the different places where these issues could arise. So definitely check those out if you're having any issues with your video showing up in BioLab. And if the preview seems out of sync, you don't need to necessarily worry too much, because not only is the preview subject to some latency, even more so than the actual video recording, but we also have tools within BioLab where we can adjust the video alignment both based on one another, if you have multiple videos, and based on the physiology after they're recorded. And we're going to talk about that more as we talk about file viewing next time. Now, the other video source we have in BioLab, which is new, is the Noldus Media Recorder. So what BioLab can do with its integration with Noldus Media Recorder is launch the application for you and start and stop recording of your audio-video files. And what makes this really exciting is that Noldus Media Recorder is very flexible and can take in video sources that the MindWare video encoder could never do, such as digital video. Now, from a BioLab perspective, the integration is pretty simple. All you have to do is tell BioLab where Media Recorder is and what configuration you want to use. And BioLab will be able to launch Media Recorder, load that configuration, and start video acquisition. All the configuration portion is done in Media Recorder, so connecting to your cameras, choosing your audio sources, things like that. They're all done in Media Recorder, and they should be done before launching BioLab and starting your session. So for those details, you can consult the Media Recorder manual, which is great at explaining all the different options that they have. All right, moving on from audio-video, we have one more tab to discuss on the configuration screen, and that is trending. So trending is basic real-time analysis available in BioLab. And with trending, you can have up to 30 trends enabled at any given time from any of the channels that you've enabled for acquisition. Some of these trends include the average, the minimums and maximums of signals. We can extract the DC and AC components of signals, things like that. We also have a more advanced trending option, which is in the same menu, and those are heart rate and respiration rate. With these, there is no artifact detection, so they are susceptible to noise corruption, but they can give you a snapshot of a person's heart rate or respiration rate at any given time. And you can use trends like the mean to look at mean skin conductance, which can be meaningful. You can look at the integral or power of an EMG signal at any given time. And so these trends are displayed during acquisition in a separate window from the rest of your data. So you could potentially use the trending window as a means for very basic biofeedback if you shared that screen with your subject. These trends are also written out to an output file. We don't ever use them in our analysis applications, but all the data is there for your own custom analysis of those real-time statistics. Okay, so now that we've gone through all of the tabs in the configuration screen, we've talked about most of the configuration options that are available in BioLab. We need to tie it all together with configuration files. So if we take all the information that we talked about today and all the information that we talked about yesterday or last webinar, we can see that configurations can be very complex. We have custom channel labels and settings per channel, filters, gain settings. We could have potentially hundreds of events defined based on their numeric values. We could have epochs that define a study even further. And all this information would be difficult or time-consuming to reconfigure every time you run an acquisition, or say every time you start up a new version of BioLab on a different computer. all of these settings can be saved to a single configuration file for later recall. Now, it's important to note that BioLab will automatically save the configuration that you're using. So if you close BioLab and you open it back up, it's going to recall all of the settings. But if you are using a single acquisition computer for multiple studies and someone else is going to be changing these settings around, it's important to preserve them using these configuration files. And you can open or save configurations by going to the settings menu across the menu bar at the top. And you could choose open configuration or save configuration as, and all of these settings will be contained into a single file. If you want to start from scratch, if you want to discard your existing configuration and reconfigure the entire application, you have reinitialize all to default. This can also be helpful sometimes if configurations become corrupt. You can reinitialize all to default and start from there and rebuild a configuration. Something that's new in BioLab 3.3 is the ability to share these configuration files with multiple computers and multiple users. So before, the configuration files were highly dependent on specific file locations of different things, such as the sync summary event file or the epoch file. But now that information is all contained within the configuration file, so it's fully portable to other systems and other users. The other nice thing about BioLab 3.3 is it can open configurations from previous versions. So in the past, when you upgrade to a new version, you'd have to reconfigure BioLab. But what you can do now is save your configuration out in your previous version and then open that configuration in BioLab 3.3, and it can fill in as much information as it has for your configuration. So use configuration files to preserve complex configurations or share them with anyone else who would want to use that same configuration. And remember that BioLab will automatically load the last configuration used. So if you're the only person using your acquisition system, then you don't need to worry about configuration files as much. But if you have multiple studies occurring using the same acquisition PC, then it's really helpful to have these configuration files so you can quickly, with the press of a couple buttons, switch between various configurations for various styles of acquisition. And another use case for configuration files would be a backup. So if you're having computer issues, hard drives sometimes fail. Things happen. And if you were to have saved your configuration into a configuration file and backed it up somewhere else, then when this sort of unfortunate event happens, you can reload BioLab, load your configuration, and you're right back to where you were without having the time-consuming process of reconfiguring or even remembering the specifics of your configuration from last time. With that, that concludes the presentation today, the walkthrough portion at least, on the remaining configuration elements of BioLab. So thank you for attending, and we are going to proceed to the question and answer portion now. If you've asked any questions, I'm going to go ahead and review them, and we'll be back in a moment. But if you do need to leave, be sure to leave some feedback on the survey on your way out, because we do genuinely appreciate and look into your feedback as we come up with new topics for webinars and change the format. So thanks again, and I'll be right back with some questions and answers. Okay, so I have a question about Noldus Observer. So there's a question as to whether or not the new integration with Media Recorder affects the current way that Noldus Observer interacts with BioLab. And the answer is no, that you should continue to integrate with Observer as before, because Observer is also capable of using Media Recorder to collect audio-video recordings at the same time. So if you're using Observer and Media Recorder currently, then just continue using it as you have been. But if you're not using Observer and you want to take advantage of some of the new video sources that Media Recorder allows for, then that's where this integration really becomes powerful. Okay, we've got another question, which is how many digital events are possible on the wireless data center? So the wireless data center, much like the 2-slot, has a smaller digital event port than the BioNex. So the BioNex consists of 8 lines, and the wireless data center and 2-slot consist of 4 lines. So in individual mode, you would have 4 individual event lines, Or in summary mode, you'd have 15 unique events that you can define. And another important aspect of those digital ports is that they are asynchronous. So they do lack the precise timing that you get with the BioNex, and they also require that timing constraint that we mentioned earlier of a 70 millisecond pulse followed by a 100 millisecond downtime. And I guess another important concept that we didn't really talk on earlier was when you're working with summary events, they don't necessarily need to be pulses. So what we're really detecting in BioLab are changes in the value at the port, not necessarily a pulse. So you could possibly go from event 5 to event 6 without ever dropping back down to 0 or turning all the lines off, and we're still going to detect that event that happened. So in all the diagrams, they were all pulses, but you could also just leave it at the previous level and change some other digital lines around, and that would still result in a new event being detected by BioLab. Okay, I've got a question. Can we wire a button or other device to the digital port to mark events? Yes, you can. Button or custom hardware can be wired to the port. It really just needs to be able to send digital pulses or change digital values. And in terms of the button, if you contact us with your specific needs, we have developed custom solutions for people in the past, and we can look at your particular needs and come up with a solution for you as well. Okay, so it looks like a user has multiple protocols which contain different summary event definitions, and they're wondering if they should use configuration files. You could. If you're using configuration files, then it will store all of your configuration information, including the summary event file definitions. But if you're using the same channel configuration for all of your studies, and you're just changing the way event markers are perceived or labeled, then you could just load a different summary event file on the Events tab. So you can always just change this summary event file name to a different name or to a different file that you've saved, and that would change all of the events that populate on that event file table. Okay, I have a question regarding keyboard events. The question is whether the event is marked when the key is pressed or when the node is finished. So this is specifically for F11 events. When the F11 key is pressed, you'll be prompted to enter your event name. And the question is whether the event is logged as soon as that dialog appears, or is it logged after you fill out the event name. And it is logged as soon as that event button is pressed. So as soon as you hit F11, that event's going to be logged in the file, and you can take as much time as you'd like specifying your event name. You're not going to lose that timing of when you press the button. Okay, I've got one more question about whether you can run E-Prime and BioLab on the same PC. So typically, labs are set up with two PC configuration if you're doing stimulus presentation. One of them is running BioLab, and the other is running your stimulus presentation like E-Prime. And that's due to the system resources that are required by both applications. BioLab, because it's integrating with a lot of different equipment and acquiring a lot of data at once, it can be demanding on a system's processor. And with E-Prime, it needs to take control of the system's display entirely to accurately display stimulus at the desired time. So while it's possible to do that, it's not recommended because you could run into a lot of issues with latency in terms of stimulus presentation and issues with BioLab keeping up and actually collecting data. So ideally, you would have two separate computers, one running stim and one running acquisition. So that's all the questions that have come up. We're going to hang out for a couple more minutes. If you have any other questions that you'd like to ask, please do go ahead and submit them. If you think of any questions later that you would like to ask, feel free to email us and we'll certainly be able to get back to you. And the webinar video will be available for review on YouTube as well as on our support site here in a few days. So we will just wait for a few more questions to come in, and we'll talk to you soon. All right, so it doesn't look like any other questions are coming in, so we're going to go ahead and wrap it up. So again, thank you so much for attending the webinar, and please do leave some feedback in the survey that you'll get when you exit, because we truly do take that to heart when we're planning our future webinars. So thanks again, and have a great day.